This is a continuation of adding probabilities, but there are more advanced problems. And I'm going to show you a different way of doing these. So basically, especially on the first one, we have an urn again that contains 7 white marbles and 5 blue. So that's total of 12. Need to know my total. And we're selecting 4 without replacement. What's the probability that the following occurs? All white or, so that means plus here, blue. Now, the standard way to do this is you're going to combine your knowledge of other ones. So, to get all white without replacement, that would be 7 out of 12 times 6 out of 11 times 5 out of 10 times 4 out of 9, or all blue, and all blue would be plus 5 out of 12, because we're selecting 4, so I had 1, 2, 3, 4 slots here. The counting principle. We're doing the counting principle here. Times 4 over 11, times 3 out of 11, times 1 or 2 out of 11. All right, and that's what you would do and put that in the calculator. Now, here's a different way to do it. I'm going to use combination thing because it's easier with the calculator. So this right here, we can write as combination of 12 total marbles taken 4 at a time. But we're going to do the white first because we're talking about white. So that's 7, and we're taking 7, and we're taking 4 out of 12, comma 4. All right? If you put this in the calculator and do this, it's the same as what you will get with this. So it's the same thing. Okay? And then for the white, we have 5 marbles that we're choosing 4 from, selecting 4 over 12, comma 4. So to me, ooh, I even did this wrong here. So let's erase this. You probably noticed that. All right, so this is 10, 9, 8. It's without replacement. So it's dependent. Anyway, so this is what I'm going to do. And I do this especially when we're choosing 4. Because that's a lot to put in the calculator. And this part here is easier. If it's just 2, I tend to do it this way. Now, when you multiply all that out, you're going to get 8 over 99. And that's your answer. Now, this is what I'm going to do on all of these. So we want exactly 3 white. So basically that means it's not even an or here. We're going to take from the white, we want 3. And from the blue, we have to have what? 1. Because you have to have 1 blue to make this exactly. So this is not even an or. And my total is 12, comma 4. So if you notice in this case, my 7 plus 5 equals my 12. And my 3 and 1 equals what? 4. Put that in the calculator, you're going to get 35 over 99. Again, you can do it this way, if you want to. I just find this way easier when you're dealing with large numbers. And you should also know that this right here equals 5. This equals 5, so we already talked about that in the previous video, so it makes it easier. All right, at least 3 white. Now, this one's a little harder. So since we're drawing 4, that means we have at least 3 white or 4 white. There's where the or comes in. So at least 3 white, we already did. We already know that that is 35 over 99. I'm going to go ahead and write it out the long way, though. So at 3 white would be the combination of 7 white taken 3 at a time, and then the blue would be here, and over my total. I could have 4 white. So there's your or. So this would be, we have to have 4 total. That means none of them would be blue. And you should know this equals 1. You should know this equals 5. Anyway. And this looks like a plus minus. I'll take that out. And when you combine this, you're going to get 14 out of 33. All right? Now, exactly 3 white or exactly 3 blue. So exactly 3 white would be the 3 white we already did. We already know which is 33. If you want, you could just write 35 over 99 here, but I'm going to do it the long way. So I'm just going to set it up. So this would be just what we had earlier. So that would be exactly 3 white or exactly 3 blue. So the blue, we have 5 blue and we want 3. So that means the white, this is m times n, the white would be 7 comma 1. Same denominator. And again, to make this easier, don't put this in the calculator. You should know that's 5. And this is what? 7. And you might even know what this is. But anyway, when you do that, you'll get 49 out of 99. All right? Now, the next one, since we're only drawing 2 cards, I'm going to do it the other way. I'm going to just not do the combination notation. We want 2 spades. So there's 13 spades. And then we assume without replacement if they don't tell you. All right. And then, so the next would be 12 out of 51. This is not even an or statement, but that's going to be 1 out of 17. 2 spades or 2 red. Well, we already know 2 spades is what? 1 over 17. And then 2 red would be, there's half the cards, or 26 of them are red. It's without replacement, so you get 25 over 51. And when you multiply that out, you're going to get 31 over 102. All right, the next one, 2 red cards or 2 jacks. In this case, just keep in mind, 2 jacks are red. So this is the one that's inclusive event. So I'm going to do the 2 reds. Or the 2 jacks, which would be 4 over 52 times 3 over 51. Now, 2 of the jacks are red. So, since we're doing without replacement here, you have to be careful here. You're not just going to subtract. This would be wrong. Okay? You have to subtract it out as if it's without replacement. So that would be 2 over 52 times 1 over 51. All right? And then when you multiply all that out, you get 55 over 2, over 221. Okay? Same thing with the spades. We have 2 spades, which we already know is what? 1 over 17, but I'm going to do it the right way. So it's 26 over 52 times 25 over 51 minus, or plus, this is ors, plus, I just changed my ors to plus, face cards. Now, how many face cards do we have? We have 12 face cards, because there's 3 face cards per suit. Remember, a face card is a king, queen, and jack. So that's going to be 12 over 52 times 11 over 51. Now, we counted face cards. How many face cards are spades? Okay, how many face cards are spades? There's 3. Because you can have the king of spades, queen of spades, and jack of spades. So in this case, we already counted those three face cards that are spades. So you're subtracting out 3 over 52 times 2 over 51. All right, and you have to think about some of these because this video is going pretty fast. And you will get 47 over 442 when you use your calculator. Okay, the last 4 problems are pretty easy. They're about dice. And we want to get only 2 5s. And what I want to, we're tossing 3 dice, and we only want 2 5s. And let's just write out what it could be. So, only 2 5s. So, we could get 1/6, 5/6, 1/6. Those are my 3 dice. Or I could have 1/6, 1/6, and 5/6. Or I could have 5/6, 1/6, 1/6. Because the 1/6 here, the 1/6 are the 5s. The 5/6 are the not 5s. And so, basically what you're going to do is multiply. Basically what you should do is just take one of these. So 1/6 times 1/6 times 5/6. And since there's 3 different combinations, you're going to multiply this by 3. And you're going to get 5 over 72. All right? At least 2 5s. So basically, at least 2 5s, we already know what 2 5s are. 2 5s are 5 over 72. The other 5, or we could get 3 5s. And let's just do this. 3 5s would be 1/6 times 1/6 times 1/6. So that would just be 1 over 216. So 2 5s would be 5 over 72. 3 5s would be 1 over 216. So 2 or 3, and when you add that up, and multiply or add it up, you get 2 over 27. And no 5s, we actually already did that. No 5s, it's just like this one. It's just 1 minus 1 over 216. Or you could just do 5/6 times 5/6 times 5/6, which gives you 125 over 216. Okay, the next video is over binomial experiments and simulations. And it's basically a different way to do some probabilities without having to write everything out. And we're going to be talking about like flipping coins, heads and tails. I hope you all have a nice day. Thank you.